Okay guys, today we're going to do 7b and we're going to be solving radical inequalities. So yesterday we talked about solving radical equations when there was equal to signs. Today we're going to talk about what happens if it's inequalities, so alligator signs, less than, greater than, stuff like that. Okay, so if you'll get out your notes, if you'll start your notes please. I'll give you a second here to write down the first example, and then we'll kind of discuss a little bit what we're going to do. All right, so we're going to talk again about radicals today, and this time we're going to talk about inequalities, like I just said. Before we start getting into solving some problems, let's discuss and review real quick what types of things, what are we not allowed to have underneath a radical? We're really not allowed to have negatives, right? Because if we get a negative underneath a radical, we end up with weird, what we call imaginary numbers, right? So let's keep that in mind when we do today's stuff, is you're really not allowed to have a negative underneath our radical, okay? So here's our example number 1. And you can write down the steps. There's going to be 3 steps in order to solve it, so I'll give you a second to write down those 3 steps. And then we're going to solve this problem using these 3 steps. Okay, so step number 1 says set whatever's underneath the radical greater than or equal to 0. Because if I have stuff underneath my radical, for example, this 5x minus 10, and if that ended up being equal to 0, what is the square root of 0? 0, right? So that's okay. But what if that number underneath the radical ended up being negative? We just talked about it, right? It would end up getting us this weird imaginary number, so we don't want that. So we need to make sure that all the stuff underneath our radical, in this case the 5x minus 10, we need to make sure that it's greater than or equal to 0. We don't want it to be negative, okay? So our first step is we're going to take this 5x minus 10, the stuff underneath my radical, and we're going to set it equal or greater than or equal to 0. Because I can be bigger than 0, I can be positive, and I can equal 0. I just can't be less than 0, okay? So let's go ahead and solve this little baby equation. We're going to add 10 to both sides. And we're going to say that 5x is greater than or equal to 10. We're going to get rid of the 5 by dividing. Now, do I have to switch my alligator sign? No, because I didn't divide by a negative, right? So I'm going to keep it the same. And I'm going to get that x has to be greater than or equal to what? 2? Okay. So, in my problem, in order for it to be okay, and in order to make sure that I don't get any imaginary numbers, negatives underneath my radical, x has to be greater than or equal to 2. Okay? But that's just the stuff underneath my radical. The next thing I have to do, step number 2, says that I have to go back through and resolve my very original problem. I can't forget about the 3 that's out here and the 8 that's out there. So let's go back through and resolve my very original problem. So my original problem was 3 plus the square root of 5x minus 10 is less than or equal to 8. Okay, so let's go back through and solve this original problem. If we're stranger danger and we want to get x by itself, who do we get rid of first? Which farthest away from that x? Isn't it this 3 that's way out here? So how would I take this 3 and move it over to the other side? Can I subtract? So left here on this left side is going to give me the square root of 5x minus 10 is less than or equal to 5, right? Okay, I still got to keep going. I've got to get x by itself. So how would I get the x by itself? What do I need to get rid of now? Well, I need to get rid of the 5 and the 10. But before I can steal the babies out of the house, what do I have to do? I got to break down the house, don't I? So what cancels out a square root? Squaring. So I'm going to square both sides. The square and the square root cancel, leaving me with a 5x minus 10 is less than or equal to 25. Let's solve for x now by adding 10. And dividing by 5. So now my answer says x is less than or equal to 7. Okay? Remember, that was only one piece of my answer. My other answer was that x has to be greater than or equal to 2. So my step number 3 is we're going to go through and we're going to graph this. And we're going to graph it so that we could check it. Okay? So when I go through and I graph it, I'm going to have two numbers on my graph. The two numbers that I'm going to have on my graph are my answers. So my answers are what? 2 and 7. So on a number line, the 2 would go first, the 7 would go next. And if you go back to the x is greater than or equal to 2, if it is x is greater than or equal to 2, which direction would my arrow go on my number line? If x is greater than or equal to 2, is it greater than to the right? Okay, so all values to the right of 2 should work. But we have to consider the other piece of our answer. The other piece of our answer was x is less than or equal to 7. So on my number line, if I want less than or equal to, which way would I go? If I want less than, wouldn't I go to the left? So what that means is that any number from 2 to what? To 7, right? Any number from 2 to 7 should work in my problem. Okay? So this would be my final answer. I'm going to put it together as a graph, so this is what your answer should look like. Okay? So what numbers would work? 2, 3, 4, 5, 6, and 7 would work, right? Because they can be equal to. So any of those numbers would work for my equation. So this is part of my answer. My other part of my answer is I'm going to put in a little equation for my answer. So I have my x is less than or equal to 7, but I also have x is greater than or equal to 2. Do you see how I switched this inequality the other way because my x was on the other side? Okay, so I'm going to have these two pieces for my answers. X is less than or equal to 7, and x is greater than or equal to 2. Okay, let's try another one. Okay, we had 3 steps, right? 3 steps. My first step was to take all my stuff underneath the radical. In this case, it's going to be a 2x plus 2, and do what with it? Greater than or equal to 0, right? So let's go through and solve that little piece. I'm going to solve this little equation by subtracting 2. By dividing by negative 2. No, by dividing by just regular 2, right? Not by a negative, so I don't have to switch my sign. I'm just going to divide by regular 2, giving me x is greater than or equal to negative 1. X is greater than or equal to negative 1. That's my first step. My second step is to do what? Is to go back and solve my very original problem. So let's do that now. So this is my original problem, and I want to solve for x, who's farthest away. It looks like this positive 1, right? So let's take this positive 1 and move it over to the other side. Let's do that by subtracting 1. That gives me the square root of 2x plus 2 is greater than or equal to 4. All right, now what do we need to get rid of? Looks like we need to break down that radical first, right? So what breaks down a square root? Square. If I square one side, I've got to square the other side. Those square and the square root cancel, and I'm left with 2x plus 2 is greater than or equal to 16. Let's keep solving. Let's subtract the 2. I get 2x is greater than or equal to, what's this, 14? Go through and divide by 2. And I get x is greater than or equal to 7. Okay? And neither of these examples had any pieces where we had to switch our alligator sign, so be careful with that. Don't forget about that rule. There might be some in your homework. There just wasn't any in the examples. But remember the rule, anytime you multiply or divide by a negative number, you've got to switch your alligator sign. Okay? All right, my last step is to make sure that I check my answers by graphing them. If I do my number line, what numbers are going to go on my number line here? Looks like -1 first, and then +7 is over on this side, right? They're both equal to, so I could do dots here. If I start with a -1, if you read this answer, this says x is what then? Greater than? X is greater than -1? Where would I draw my arrow then if it's greater than? To the right? Let's do the 7. If you read this answer, this says x is greater than, right? X is greater than 7. So wouldn't I graph my arrow that way again? That kind of looks weird, doesn't it? We don't ever have graphs that are pointing the same direction. And why is that? Well, this is saying that in order for my problem to work, x has to be greater than -1. Has to be greater than or equal to -1. But it's also saying in order for this equation to work, x has to be greater than 7. Well, it can't be greater than 7 and greater than -1 at the same time. So what are the only answers that are going to work all the time? Isn't it going to be this piece of the graph? Because I can't be any less than 7. That's what this answer is saying. I have to be bigger than 7. So I can't be less than 7 and work. So my only answers that are going to work on this problem is where x is what? Greater than or equal to 7. The -1 is not going to work all the time, so I'm not going to include that in my graph, and I'm not going to include that in my answer here. Okay? So that's why graphing it helps us. If you're ever going the same direction, you probably did something wrong. Okay? Or part of your answer doesn't make sense or doesn't work. So make sure you pick the part that does make sense and work. Okay? All right, because I can't be bigger than 7 and then be down here in this space. So make sure you pick the right answer. So what happens if I have this? I don't know, I'll just make up some numbers here. Let's say I was -3 and +4. And I wanted to be less than -3 and less than -4. What would my final answer be? What would be the only numbers that would make sense and work all the time? Wouldn't it have to be the pieces that were all less than -3? Because I can't be less than -3 and be over in this area, right? So this piece of my graph would not work. My only answer on this equation would be x is less than or equal to whatever, -3. Okay? All right, you'll have some more practice today on your homework. Before I give you your homework, I'd like you to try one on your own. Will you try this one for me, please? I'd like you to get all the way down to an answer and a graph. I'll give you a few minutes. got x is greater than or equal to 1 for the first part. Did you? None of these examples today, bummer, had a problem where you had to switch your alligator sign. There is one question though on your homework where you will, so please be careful. Okay? On this one I got x is less than 10. So I got x is greater than or equal to? Oh yeah, greater than or equal to. Why? Because it's supposed to be greater than or equal to 0. But on this one I got x is less than 10. So let's graph it. 1 goes first, 10 goes next. On my 1, I'm going to have a closed circle because it is equal to. And it says x is greater than 1, so I'm going to go this direction, to the right. On my other answer, it says x is less than 10. X is less than 10, not equal to, but just less than. So I'm going to do an open dot, and less than is this way. So those numbers make sense. That means from 1 would work, 2 would work, 3 would work, 4 would work, 5 would work, 6 would work, 7 would work, 8 would work, 9 would work. Would 10 work? No, it has to be less than 10. But doesn't that make sense when my arrows are pointing together and all the numbers in between would work? All right, so that's part of your answer, along with your equation. So we have x is less than 10. Switch your alligator sign around and say that x is greater than or equal to 1. Okay? All right, for each of these problems, make sure you set underneath greater than or equal to 0. Make sure you solve your very original problem and then put it together on the graph. Your arrows should be pointing the same direction, either together, pointing toward each other, or pointing toward each other, I think, right? You should be pointing toward each other. If they're pointing in the same direction, you need to find the answers that make sense, that are going to work all the time, okay? Your homework is 7.7b worksheet. I expect it to be done and correct